Kinematics describe motion. In this video, I'm going to use 6 properties of kinematics: time, distance, displacement, speed, velocity, and acceleration to help you understand kinematics in 30 minutes. We can describe motion using kinematics and dynamics. Kinematics describe motion and dynamics, of course, explains it. Today, I'm going to show you kinematics in half an hour. Using 3 problems and 6 properties of kinematics: the time, distance, displacement, velocity, speed, acceleration, of course. And then 3 problems. The first problem would be 3 problems. So first problem would be has to do with the vertical motions. An object from 45 meters above the ground. So you have to do the dt, vt, and at graph for 3 locations: at the end of first second, at the end of second second, and at the end of third second. The second problem is the horizontal motion. Let's say first we're going to solve problem 1, and we're going to start our conversation by the time, and then you have a distance, and you have a velocity, and you have acceleration. So the time, let's say this is 1 second, and then end of 2 second, end of 3 second, and end of okay, now let's start with 0 second. 0 second, end of 1 second, end of 1 second, end of 2 second, end of 3 second. Okay, so now then at 0 second, of course, this is here, the distance at 0 second, this is here, and the distance at end of 1 second is here. The distance at end of 2 second, I'm gonna make it closer, 1 second over here. End of 2 second, I'm going to have it over here. End of 3 second, I'm going to have it over here. So the distance, how can we find the distance? Distance is, remember, distance is, what is the distance? Distance is VAT plus half AT squared. And the velocity is VI plus AT, of course. And the G for us would be, we're going to use 10 meter per second squared for simplicity, so we don't have to use the calculator, of course. So now the distance travel, the distance, this one would be 5 meters at the end of 1 second, and this travels 5 meters. At the end of 2 seconds, it travels 20 meters, and at the end of 3 seconds, it travels 45 meters. Okay, now let's talk about the velocity. The velocity would be, at the end of 1 second, the velocity is 10 meters per second. At the end of 2 seconds, the velocity would be 20 meters per second. At the end of 3 seconds, the velocity would be 30 meters per second. Okay, now let's find the acceleration. What do we know about acceleration? Acceleration is delta t. Acceleration is delta v over delta t. Okay, so this one is 0, so this is 0, this is 0, this is 0. All right, so delta v, so 10 minus 0 divided by 1 is 10. So acceleration is 10, acceleration 20 minus 10 divided by 1 is 10. 30 minus 20 divided by 1 is 10. So acceleration, what we learn from this problem, we learn that the acceleration is constant, the velocity is increasing, and then the distance of course increase quadratically, and the velocity increases linearly. All right, and of course the acceleration remain constant. It doesn't depend on the time. Now I want you to draw dt, vt, and at graph. Okay, so let's do dt, vt, and at graph. Okay, so we're going to do it here on the corner. Dt, so dt, this would be our dt, this would be our vt, and this would be our at. Okay, so the dt would be the quadratic second degree polynomial, and the function would be p of t would be 5t squared, because half times, so this is 0, this is half times 10 t squared, so 5t squared. And then this one would be 10t, and this one would be of course just 10. So this would be dt, bt and at graph. Okay, so this is the problem number 1. Mr. Berry went on through a 1.5 hour long bike trip, and his position function is 40/3t squared. Find his final velocity. Right, t1 is equal to 0 and d1 is equal to 0. You're going to call it 0.1. We're going to call t2 is 0.5 and d2 is 0.3, and we're going to call 0.2. 0.3 we're going to call t3 is equal to 1 and d3 is equal to 13.3. 0.4 we're going to call t4 is equal to 1.45. 601, and then finally we're going to have 0.7. t7 is 1.5 and d7 is of course 30. Okay, so I found those values using this position function, of course. Velocity final, that means what would be the velocity right here, velocity final, not the average velocity, velocity final, instantaneous velocity, velocity at right here. Okay, so if there is a speed limit sign over here and the speed limit is 38 mile per hour, did Mr. Berry break the law? That's what we're going to try to find out. What would be the velocity at P7? Okay, P7 to P1, P7 to P2, P7 to P3, P7 to P4, P7 to P5, P7 to P6, and P7 to P7. P7 to P7 is it doesn't exist. It's undefined because P7 to P7 is going to be 0/0 because 30 minus 30 over 1.5 minus 1.5. Algebra breaks down at right here. So this is no good. Delta t. Okay, so the delta t between these two. Is the time go to 0? Well, let's see. 1.5. Not really. Is the time between these 2 points goes to 0? Well, maybe let's see. 1. Is the time between these two goes to 0? Well, 0.5. Well, okay, all right. This seems like the time is getting 0 between these 2 points. Okay, let's see whether we can make more progress. 0.05. Is this time between these two is getting 0? Let's see. 0.02, 0.01. It seems like the time is getting 0. The time is getting 0 between these two numbers. Okay, between these 2 points. Okay, good. Now let's see the distance. All right, or displacement for that matter. The displacement would be between these 2 points would be of course 3399. Of course, now we're going to find the velocity. Divided by 1.5 would be 20. So that would be the average velocity. We're going to call average velocity. And that would be the average velocity. Okay, that would be the velocity entire trip. All right, if we draw it, this would be the velocity. This would be the velocity. Okay, this would be the velocity. All right, so 0, 0, 1.5, 30, and that will be this, and so the velocity of this one is 20 mile per hour. So this is the average velocity. Okay, get it? All right, so this one would be 26.7. All right, so as we said that as this approaches to 0, this approaches to 40. Let's see whether that's true. 16.7 divided by 0.5 is 33.4. 1 point is approaching to 0. I already see that. 1.97 divided by 0.05. 39.4. Okay, is approaching to 0. 0.795 divided by 0.02. 39.75. All right, and then finally 0.399 divided by 0.01, 39.9. As you see that as the delta t approaches to 0, delta t approaches to 0 from 1.5 hour to 1 hour, 2.5 hour, 2.05 hour, 2.02 hour, 2.01 hour, which is almost 0. Then the velocity approaches to 40. How? 20 to 26.7 to 33.4 to 39.4 to 39.75 to 39.9. Of course, now the physics also tells us the same thing. Okay, let's see. First, we're going to use the distance formula. So the distance is VIT plus half AT squared. So 30 is equal to, this is 0 because you start at 0. All right, so the t is 0, so that's why this is 0. Half a 3 over 2 squared. So you have 30 is equal to half a 9 over 4. Okay, so you have 60 is equal to 9 over 4a. So 4 over 9, 4 over 9. All right, so a is equal to 240 over 9. Okay, 240 over 9. So this is our acceleration. Now let's find the final velocity. Final velocity is vi plus at, and vi is of course 0. Velocity initial is 0. Okay, so vf is a is 240 divided by 9 times t is 3 over 2. Okay, 3 goes to 9 3 times, 3 goes to 2 goes to 80, 40. So VF is 40, okay, mile per hour. So of course the physics also tells us that at right here the velocity is 40. We call it instantaneous velocity. Now right here, so this is the algebraic technique of finding the velocity. What is the velocity formula? Velocity formula is d final minus d initial is t final minus t initial. Okay, so the d final minus d initial would be what? At right here, d final minus d initial would be, okay, so we got that over here, 0.399, and that divided by 0.01, and that gave us 39.99. 39.99. You cannot put 30 minus 30 divided by 1.5 minus 1.5. However, we can use the calculus. You have the position function p of t is equal to 40 over 3t squared. Now this is called the derivative, and how do you take the derivative? Derivative is very easy. You have x n is x n minus 1, okay, and you put n over here, and that's it. That's how you take the derivative. So what is our n? This is our n. So p of t, we're going to call it p prime of t, which is the velocity, is equal to, we put the 2 over here, 40 over 3 t 2 minus 1. So now we, instead of p prime of t, we're going to call it vt, because if you take the first derivative you get it velocity. So 80 over 3 t, because 2 minus 1 is 1. So velocity at 1.5 is 80 over 3 1.5, which is at 1.5 velocity is 40 mile per hour. You do not need to do this way, and I should tell you, you must not do it this way. This is not allowed in this elementary level. I gave you 3 ways of doing this. One is this way, and other one is of course this way. Mr. Barry drives from home to work, right? Drives from homes to work. Let's say Mr. Barry drives from, this is Mr. Barry's home, this is Mr. Barry's work, and this is 20 mile apart. So he drives from here to here 40 mile per hour, and he immediately turn around and go back with 60 mile per hour. Draw dt, vt and at graph for this problem as well. The home to work, so this is my home, this is my work. After I arrive at work, I immediately return to home. So from home to work, I was moving 40 miles per hour, and from work to home, I was moving 60 miles per hour. All right, I want you to find the average speed. Okay, so let's find the average speed. To find the average speed, average speed is distance over time. So you have two types of distance. You have the black distance and the green distance. So we're gonna say speed is d1 plus d2 over t1 plus t2. The d2 and t2 is supposed to be green, okay? But bear with me. d1 is equal to d2 is equal to d. So we're going to say 2d is equal to t1 is of course d over v. So d is 40 over d is d and 40. t2 is d over 60. So d over 40 plus d over 60 is going to be 120, 5d over 120. So 5d over 120. So speed is 2d times 120 over 5d. dd cancel, 5 goes to 24. So speed is 48 mile per hour. All right, that's the speed. Now we're going to find dt, vt, at, and the other graphs. So number 2, this is number 1. Number 2, we're going to find dt graph. Number 3, we're going to find displacement versus time graph. Number 4, we're going to find speed versus time graph. Number 5, we're going to find velocity versus time graph. And there is no acceleration versus time graph because acceleration for the problem is 0, of course. All right, so let's find the dt graph. So for the black one, from home to work is the dark. Let's make home to work is the blue. So home to work is the blue. Okay. All right, so home to work is the blue. So T1 is the blue. Make it thinner. T1 is that. So T1 is the blue, and D1 is the blue. D1 is also the blue. Okay. All right. So now distance. So this is gonna be the home to work, and this is gonna be the work to home. Okay. And displacement. All right. So we're gonna put the time over here. The time is all right. So the distance between home to work, I use the home to work is 120 mile. That's I know, that's given. All right, so this is the distance, right? So this is at what time? The T1. So T1 is 120 over 40. So T1 is 120 over 40 is 3. 120 over 60 is 2. So this is 3, and this is 5. This is 5. Okay. All right. So at 3 the distance is of course the 120. At 5 the distance is 240. Okay. Now let's do this one. Okay, so this is a little flat, but this is steeper. This is the green one is steeper. Okay, so right here is 120. All right, and right here is the time is the time is 3 and the time is 5. Okay. All right, so what is the total displacement? Total displacement is 0. What is the total distance traveled? Total distance traveled 240. Okay, all right, now we're going to do speed versus time. All right, so let's do speed versus time. Again, we're going to do the blue and green. All right, so the blue, you have green. All right, so not that much. Okay, so this is the area under, oh, this is speed, so speed cannot be negative. Very nice. So speed, all right, so I'm going to do this and then this. Okay, all right, so let's shade it. This is the area under the speed versus time graph. This is area under velocity versus time graph. This is area under velocity versus time graph. Okay, so now let's put some point. So this is 2, this is 5, this is 3, and this is 5. And this one is speed, this one is of course 40, and this one is 60. Now let's do the blue first. The blue is BH, so BH plus the green is I don't know, also BH. All right, so the blue is BH, so what would be the B? B would be the blue is B would be base 3 height 40 plus base 2 height 60. So 120 plus 120, 240. Okay, good. So the total distance is 140. Okay, now we're going to do velocity versus time graph. All right, so velocity versus time graph would be what? So velocity versus time graph. So let's see. So the blue one is this, and the green one is this. Okay. So let's put some number. Blue one, of course, is 40, and the green one, of course, is negative 60. And we know over here is, over right here is, we know over right here is the time is 3 and time is 5 over here. So we're going to find the blue, and then we're going to find the green. All right, so what is the blue? Let's see, let's find the blue. Blue is BH, so B is 3 and H is 40, so it seems like this is 120. Let's see the green. The area is BH, so base is 5 minus 3, 2, height is negative 60, so this is negative 120. Positive 120, negative 120 is 0. So area under the VT graph, velocity versus time graph, is 0. Okay, so what are we going to call it? We're going to call it displacement. What are we going to call it? Distance. So the distance traveled 240 miles, and displacement traveled is 0 mile. All right, so this is your 1D kinematics in half an hour. Next time we're going to do 2D kinematics in half an hour. Write any question you may have down below that you don't understand.